Ancient civilizations have left us with secrets that modern science still can't explain. Among these mysteries are materials that seem too advanced for their time. Today we will explore 10 ancient materials that modern science has yet to recreate. These discoveries challenge everything we know about ancient innovation and raise a question: what have we lost throughout history? Let's begin with Top 1, Roman concrete. Top 1, Roman concrete. Roman concrete, known as opus cementicum, is a material that has stood the test of time. It has been found in many ancient Roman harbors, breakwater structures, and other coastal constructions, and has withstood the ravages of the sea for over 2,000 years, something that modern concrete cannot do. Modern concrete often deteriorates and erodes after just a few decades when exposed to seawater, but Roman concrete only becomes stronger over time. This mystery of how a material can improve its durability over time has intrigued scientists for decades. The secret to its strength lies in its unique composition. Unlike modern concrete, which relies on Portland cement, Romans used a mixture of volcanic ash, lime, and seawater. The volcanic ash, known as pozzolana, reacts with the lime and seawater to form a rare mineral called aluminum toberite. This mineral interlocks at the microscopic level, creating a structure that continues to strengthen over time as it is exposed to water, especially seawater. What makes Roman concrete so extraordinary is its ability to grow stronger with age. This is in stark contrast to modern concrete, which tends to weaken and crack over time. The reason Roman concrete is so durable lies in its mineral structure. The mineral, aluminum toberite, is a byproduct of volcanic ash and seawater. It forms a crystalline structure that grows over time, making the concrete even stronger when exposed to marine environments. Modern scientists have discovered that the longer Roman concrete is in contact with seawater, the more robust and solid it becomes. Scientists have made multiple attempts to replicate Roman concrete. In the early 2000s, researchers collected core samples from ancient Roman harbors in locations such as Caesarea and Kos, and found that the concrete was still intact after 2 millennia. Despite understanding the mineralization process, modern attempts to replicate the exact mixture of Roman concrete on a large scale have been unsuccessful. One of the primary reasons is the volcanic ash used by the Romans, which is sourced specifically from the Bay of Naples, an area rich in unique volcanic materials. Modern construction materials cannot replace this specific ash, and without it, modern concrete fails to achieve the same results. Furthermore, the method of making Roman concrete was a slow, underwater curing process. Unlike modern concrete that sets quickly in a matter of hours or days, Roman concrete required a much longer curing time, especially in water. The process could take weeks or even months to fully set, allowing the minerals to bond properly over time. This lengthy curing process is something that cannot be achieved with modern, fast-setting concrete used in today's construction industry. Scientists have tried to replicate this curing process, but modern timelines simply do not allow for it. Despite these challenges, Roman concrete holds the potential to revolutionize modern construction. Imagine using a material that is more durable than modern concrete, able to withstand the elements for centuries longer than today's materials. If Roman concrete were used in the construction of modern dams, bridges, and coastal defenses, it could potentially save trillions in repair costs and environmental damage. However, the suppression of research into Roman concrete raises important questions. Why is there such little incentive to revive this superior material? What industries benefit from the fragility of modern concrete? Could there be a hidden agenda preventing us from rediscovering ancient technologies that could significantly improve modern construction? Top 2, Damascus steel. Damascus steel is one of the most legendary materials in history, known for its incredible strength, flexibility, and the beautiful swirling patterns embedded within its surface. These blades were said to be able to slice through metal and even rifle barrels without chipping, and they could bend nearly 90 degrees without breaking. But the true mystery of Damascus steel lies in its creation, an ancient process that modern scientists still cannot fully replicate. The unique patterns seen on Damascus steel are not decorative. They are the result of carbon nanotubes and carbide structures that form during the forging process. These microscopic structures give the steel its legendary properties: extreme strength, sharpness, and flexibility. While modern metallurgy uses high-tech tools like electron microscopes and laser cutters to understand the composition of metals, replicating the exact process that created Damascus steel has proven to be impossible. The process of creating Damascus steel involves smelting iron ore with organic materials such as wood chips and dried leaves in a sealed crucible, which created a low-oxygen environment. This allowed for precise carbon absorption, forming the high-carbon steel that was then hammered, heated, and cooled in a rhythmic cycle. The careful balance of temperature, time, and pressure was essential to the creation of the steel. Even the slightest variation could ruin the process, causing the steel to become brittle or uneven. Despite modern advances in metallurgy, no one has been able to replicate the specific carbon distribution that makes Damascus steel so resilient. In 2006, researchers were able to identify nanowires of iron carbide embedded in the authentic samples of Damascus steel, structures that only form under narrow thermal conditions. The knowledge required to achieve these results was passed down orally by ancient smiths, making the process incredibly delicate and difficult to master. These craftsmen spent generations perfecting the technique, refining it with each iteration. But one of the greatest mysteries of Damascus steel is the source of the raw materials. Some scholars believe that the ores used to create Damascus steel contain trace elements like vanadium and molybdenum, which are found in specific mines in southern India. Unfortunately, those mines have since been depleted or altered. Attempts to use similar ores have failed to replicate the steel's properties, as the exact trace elements are no longer accessible. It is possible that the secret to creating Damascus steel lies in the lost plants used during the forging process. These plants may have been used to create a special carbon-rich environment inside the crucibles, but they are now extinct. By the 18th century, the true art of making Damascus steel had vanished. As colonial powers and European metallurgical techniques spread across the globe, indigenous crafts like the making of Damascus steel were suppressed. Local blacksmiths, once revered for their ability to forge this exceptional steel, saw their knowledge replaced by European industrial methods. The oral tradition that had passed the secrets of Damascus steel down through generations was disrupted, and the craft disappeared. Today, there have been attempts to recreate Damascus steel in modern times, particularly in military technology and aerospace industries. In 2018, a leaked memo from an Indian military research agency described an alloy based on pre-colonial metallurgy that exhibited anomalous fatigue resistance, a property similar to that of Damascus steel. But no public studies or publications have emerged from this research, and it is believed to be classified. Why is there so little funding for the revival of Damascus steel? Could the knowledge of how to make it be deliberately suppressed because of the potential disruption it could cause to modern materials industries? If Damascus steel could be revived, it could revolutionize industries ranging from military technology to aerospace and even medical tools. Imagine the possibilities if we could create blades that never lose their edge, or materials that are stronger than steel, yet flexible enough to bend without breaking. But why does the pursuit of this ancient knowledge seem to be hindered? Is there a reason why we are denied access to such a profound piece of our technological history? Top 3 Orichalcum alloy. In 2015, marine archaeologists made a groundbreaking discovery off the coast of Sicily. Beneath the sea, they uncovered 39 ingots of an unknown metal, unlike anything they had ever seen before. These ingots, despite being submerged for over 2,600 years, retained a bright golden red sheen, seemingly immune to the ravages of time and corrosion. The ingots were initially thought to be gold or bronze, but upon closer inspection, they were found to be a completely unique alloy. This discovery led to the belief that they had found orichalcum, the legendary metal of Atlantis. In Plato's Critias, orichalcum is described as the second most precious metal in Atlantis, second only to gold. It was said to adorn the inner sanctums and temples of the city, prized for its rare beauty. For centuries, historians dismissed this as allegorical, a symbolic element of Plato's story. However, the discovery of these ingots has sparked a rethinking of the myth. The ingots were made of a complex alloy consisting of copper, zinc, nickel, lead, and trace amounts of rare earth metals, materials that, when combined, created a unique and previously unknown metal. But what puzzled scientists was the purity and balance of the elements used in the alloy, which couldn't be replicated by modern methods. The key to the mystery lies in the unusual properties of the metal. Orichalcum has a distinct sheen and spectral fingerprint, unlike any known metal. Modern metallurgists have attempted to replicate the metal's characteristics using advanced technologies, but so far all attempts have failed. The alloy's composition suggests that it was formed using a highly controlled process, one that required precision and specific environmental conditions, something the Byzantines or any ancient civilization would not have had access to. The cooling process, in particular, was slow and deliberate, allowing the metals to bond in a way that modern metallurgy cannot reproduce. Some researchers believe that orichalcum could have had more than just ornamental value. It could have been used for technological applications, such as energy transmission or signal shielding, especially considering its conductive properties. This could explain why the discovery of the metal has been met with such resistance and secrecy. After the ingots were discovered, access to them was restricted by the Italian Ministry of Culture, and all updates on the analysis were suddenly stopped. Researchers were denied further samples, and the ingots were moved to a state facility for preservation. Could it be that orichalcum's rediscovery posed a threat to modern technology? What if the secret to creating such a metal holds the key to revolutionizing industries in energy, aerospace, or military applications? The suppression of further research into orichalcum raises more questions than answers. Some believe that this metal, if recreated, could disrupt current technologies, especially those tied to material sciences. And if orichalcum is truly a lost science of material fusion, what else has been buried from the knowledge of ancient civilizations? Why is such an advanced material being kept hidden? Is it because it challenges the very foundation of our modern industrial world? Top 4. Mesopotamian lenses. In 1850, while excavating the ruins of the ancient Assyrian city of Nimrud in northern Iraq, archaeologists uncovered an intriguing object buried within the temple ruins. It was a small, oval-shaped piece of rock crystal, smooth, convex, and with an uncanny clarity. Initially dismissed as a decorative item, it was later revealed to be one of the oldest optical devices ever found, the Nimrud lens. Dating back to around 750 BCE, this lens was made from natural quartz and measured only about 1.6 inches in diameter. What makes this discovery so remarkable is that it could magnify objects 2 to 3 times, a feat that suggests the ancient Mesopotamians understood optics long before the Greeks or Romans. The precision with which this lens was crafted is evidence of an advanced understanding of how light refracts when passing through curved surfaces. This lens wasn't an isolated artifact either. Similar polished crystal lenses have been found at Mesopotamian, Sumerian, and Babylonian sites, many of which were originally assumed to be simple jewelry or ritual items. However, closer inspection revealed that many of these lenses demonstrated optical properties too precise to be accidental. In 2007, researchers at the University of Geneva re-examined 13 such lenses using laser interferometry. The results were astonishing. Several of the lenses exhibited the perfect curvature needed to create controlled focal lengths, which is essential for optical instruments like telescopes or microscopes. The discovery challenges the conventional view that lens making began with the ancient Greeks or Romans. If the Mesopotamians had mastered the art of lens making, could they have used these lenses for astronomy? Could they have observed planets, stars, or even microscopic life with this technology? And if so, could the knowledge of optics have been far more advanced than we ever imagined? This discovery also raises the question of why these lenses were so widely used in a culture that did not have the advanced technology we associate with microscopes or telescopes. Were these lenses part of an astronomical tradition, or perhaps used for precision carving, surgery, or other highly specialized tasks? The evidence that the Mesopotamians may have been using lenses for astronomy is particularly intriguing. Star charts found in the same region suggest they had a deep understanding of the night sky, far earlier than we once thought possible. Could these lenses have helped them study the stars with a precision that was lost until the Renaissance? Despite the significance of these findings, Many of these lenses remain locked away in museum vaults or classified in artifact archives. Requests to have them reclassified as scientific instruments have been repeatedly denied. In 2012, an expert in optics from a German research institute was even barred from examining a collection of Mesopotamian lenses at the British Museum. The official reason? Preservation concerns, yet no such restrictions were placed on other quartz-based artifacts. What if these lenses were part of a larger optical system used to measure the heavens or perform precise medical procedures? The possibility that the ancient Mesopotamians had optical instruments centuries before the Greeks changes everything we thought we knew about the development of science. Top 5. Egyptian antibacterial gold powder. In 1924, archaeologists uncovered something unusual while cataloging artifacts from the tomb of High Priest Ankh-Khor at the Saqqara site in Egypt. What appeared to be a layer of gold dust covering the inner wrappings of his mummified body was initially believed to be just a symbol of wealth or a ritualistic item, as was common in Egyptian burials. However, closer inspection revealed something extraordinary. This wasn't ordinary gold dust. Microscopic analysis conducted later at the Cairo Museum revealed that the gold particles were nanoscopic, each flake measuring less than 50 nanometers in diameter. What was even more astonishing was the discovery that the gold dust exhibited antibacterial properties. When tested against bacterial colonies such as E. coli and Staphylococcus aureus, the particles killed over 99% of the bacteria within just minutes. Unlike modern antibiotics, which rely on chemical reactions, this gold powder seemed to act in a mechanical way, likely by puncturing the bacteria's cell membranes. This discovery raised significant questions. How could the ancient Egyptians, thousands of years before the advent of modern nanotechnology, have created gold nanoparticles with such precise control? Today, creating uniform nanoparticles requires advanced laboratory equipment, centrifuges, chemical baths, and electronic monitoring. But the Egyptians achieved this remarkable feat with no advanced tools. Some researchers speculate that plant enzymes may have been used in the mummification process to break down the gold into nanoscale particles. The presence of pollen grains from rare desert plants found within the wrappings of the mummy suggests that organic compounds could have played a role in stabilizing the gold particles. The implications of this discovery are mind-blowing. If the Egyptians had mastered nanotechnology long before modern science, they might have had an understanding of the antimicrobial properties of materials, an understanding that we are only now beginning to explore. Gold nanoparticles are used today in a variety of medical applications, from drug delivery to wound healing, and the ancient Egyptians may have been the first to harness these properties. Yet after the discovery, the gold powder samples were quietly removed from public display. Official records now list the particles as gilded dust, and the research on their antibacterial properties has largely been suppressed. In the 2000s, a prominent biochemist in Switzerland claimed to have recreated the effects of the gold powder using ancient recipes, but his funding was pulled and his research was shut down before it could be published. Was this discovery too disruptive to the modern scientific establishment? Could it be that the ancient Egyptians had mastered a form of infection control far ahead of its time, and that this knowledge was deliberately hidden? If the Egyptians had truly discovered the power of nanoparticles and used them for medicinal purposes, it could have transformed modern medicine. But the loss of this knowledge raises a troubling question. What other advanced technologies were the ancient civilizations capable of that we have yet to rediscover? What has been intentionally buried under the sands of time? Top 6. Greek fire. In 678 CE, during a decisive naval battle off the coast of Constantinople, the Byzantine navy unleashed a terrifying weapon that would go down in history: Greek fire. Jets of fire erupted from Byzantine ships, clinging to the surface of the water, setting everything in its path ablaze. This fire, unlike any other, could not be extinguished by water. In fact, it burned even more violently when doused in water. Witnesses described it as an almost living flame that seemed to spread uncontrollably. For centuries, Greek fire was one of the most feared weapons, but its exact formula remains a mystery to this day. Greek fire was deployed using siphon-like devices mounted on warships, suggesting that the Byzantines had a pressurized delivery system, an innovation far ahead of its time. But the real mystery lies in the composition of the fire itself. Descriptions of the weapon suggest it could burn on water, stick to its targets, and continue burning even when thrown into the sea. Properties that modern scientists have been unable to replicate. The ingredients of Greek fire have been a topic of speculation for centuries. Some historians believe it was made from a mixture of quicklime, naphtha, sulfur, and bitumen. While these ingredients are known, they don't fully explain the fire's incredible resilience and its ability to burn underwater. In 2003, a team of researchers at the University of Thessaloniki came close to replicating the properties of Greek fire by producing a gel-like flammable substance that could burn on the surface of water. However, this modern version required synthetic stabilizers and artificial chemicals, materials that were unavailable during the Byzantine era. The formula for Greek fire was kept a closely guarded secret by a select group of Byzantine artisans. These artisans passed down the secret from generation to generation, ensuring that the formula would remain hidden from outsiders. The secrecy was so extreme that anyone who attempted to reveal the secret was executed. When the Fourth Crusade captured Constantinople in 1204, the secret of Greek fire was lost. All records of its composition were either destroyed or deliberately hidden. In the 1970s, declassified reports from NATO mentioned a substance that could ignite when in contact with seawater, GFR7, a substance believed to have been used in ancient incendiary weapons. However, tests on this material were abruptly halted, and the substance was never identified. Since then, access to ancient Byzantine shipwrecks has been restricted, and researchers have reported finding sealed amphoras containing tar-like residues that might be remnants of Greek fire. Why are these sites being sealed off? Could Greek fire have been more than just a weapon? Could it have been a chemical technology capable of defying natural elements? A technology that could revolutionize modern energy transmission or military applications? Could the knowledge of Greek fire pose such a threat to modern technology that it has been deliberately erased from history? The secrecy surrounding Greek fire raises the chilling possibility that we are not only missing ancient weapons, but entire technologies that have been lost to time. Top 7. Wootz steel. In 1795, a shipment of swords arrived at the Royal Arsenal in London. Among them was one particularly striking sword, a curved blade with a unique, flowing pattern that seemed to shimmer like liquid smoke trapped inside the metal. This was no ordinary sword. It was forged from Wootz steel, a material so renowned that it had been used across the Middle East and India for centuries. What made these swords extraordinary wasn't just their beauty, but their remarkable strength and flexibility. These blades could slice through European steel without losing their edge, and they could bend nearly 90 degrees without breaking. Wootz steel was legendary for its ability to retain its sharpness, yet bend without snapping, making it ideal for the weapons of warriors across the ancient world. The steel's secret lay in its production process. Unlike modern methods, Wootz steel was made by smelting iron ore with organic materials like wood chips or dried leaves in a sealed crucible. This low-oxygen environment allowed for precise carbon absorption, producing high-carbon steel with a unique structure. The pattern you see on Wootz steel, known as the damask pattern, wasn't just decorative. The intricate swirls and waves embedded in the surface of the steel were a result of carbon nanotubes and carbide structures that formed during the forging process. These microstructures provided the steel with unmatched durability and flexibility, making it superior to anything modern metallurgy could produce. Yet despite this, modern metallurgists have been unable to replicate the process with the same consistency. Even with advanced technologies like electron microscopes and laser cutting techniques, the precise method of creating Wootz steel remains a mystery. The challenge in replicating Wootz steel lies in the specific raw materials used. Ancient texts suggest that the ores used to create Wootz steel were rich in unique trace elements like vanadium and molybdenum, which are found in certain mines in southern India. However, these mines have long since been depleted, and modern attempts to use similar ores have failed to replicate the steel's extraordinary properties. In addition, the plants used to create the low-oxygen environment in the crucible may be extinct, leaving another key variable lost to history. The process of creating Wootz steel was an incredibly delicate one. Even the slightest variation in temperature or atmosphere during the forging process could ruin the entire batch of steel, making it brittle or uneven. This made the technique extremely difficult to master and pass down through generations. By the 18th century, the knowledge of Wootz steel began to fade, and European industrial methods took over, replacing the ancient craft. The oral traditions passed down by generations of Indian blacksmiths were lost, and by the time of British colonial rule, the art of making Wootz steel had essentially vanished. Despite modern advancements in metallurgy, no one has yet been able to consistently replicate the qualities of Wootz steel. Some researchers have attempted to recreate it, particularly for use in military technologies and aerospace, but with little success. In 2006, a team of researchers discovered nanowires of iron carbide in authentic Wootz steel, structures that only form under extremely specific thermal conditions. These findings have raised the possibility that the ancient smiths who created Wootz steel may have had an understanding of nanotechnology long before modern science. What if Wootz steel had been the key to creating stronger, lighter materials used in everything from military weapons to spacecraft? If we could unlock the secret of Wootz steel, it could revolutionize everything from aerospace engineering to medical tools. But why has the knowledge of Wootz steel remained so elusive? Could the suppression of this technology be part of a larger effort to keep certain advanced materials hidden from the modern world? Top 8 Libyan Desert Glass. In 1932, during an expedition across the Great Sand Sea, which straddles the border between Egypt and Libya, British geologist Patrick Clayton discovered something extraordinary. Scattered across the desert floor were shards of yellow-green glass, so distinct from anything formed by natural erosion. These glass fragments were razor-sharp, smooth to the touch, and unlike anything the scientists had encountered. Over time, geologists would uncover more than 3,000 square miles of this material, now known as Libyan desert glass. However, it wasn't just the glass's rarity that fascinated researchers, it was the mystery of its origin. Libyan desert glass is made of over 98% silica, giving it an incredible clarity and consistency. What sets it apart from other glass is its unique formation. To create glass from quartz sand, temperatures must exceed 3,000 degrees Celsius, yet there are no known volcanoes in the region and no evidence of lava flows, geothermal vents, or impact craters, the usual sources of extreme heat capable of melting sand into glass. So the question remains, how was this glass formed in the middle of the desert without an obvious heat source? One possible explanation is that the glass was created by a cosmic event, such as an asteroid explosion or comet airburst that released extreme heat upon entering Earth's atmosphere. This would have created a fiery explosion that melted the sand into glass, without leaving a crater or any visible damage to the surrounding landscape, similar to the 1908 Tunguska event in Siberia. This event is believed to have been caused by a cosmic body detonating in the atmosphere, releasing heat and energy without touching the ground. Yet the mystery deepens. The glass contains rare minerals that require extreme heat and pressure to form, such as castabolite and latolite. These minerals are found only in environments with intense energy, suggesting that the formation of Libyan desert glass involved more than just a sudden burst of heat. The microstructures within the glass point to a slow cooling process, something that artificially controlled conditions in a laboratory would struggle to replicate. This raises the question, could this glass have been created by something far more advanced than the natural processes we know today? Libyan desert glass is also tied to ancient history. A scarab carved from this glass was found in Pharaoh Tutankhamun's burial mask, indicating that the ancient Egyptians valued the material for its beauty and believed it had mystical or even technological properties. The Egyptians were known for their knowledge of materials and advanced craftsmanship, but could they have understood the unique properties of this glass and used it for more than just decorative purposes? Perhaps they knew something about its energy conduction or other properties that we have yet to understand fully. After its discovery, Libyan desert glass has been the subject of much speculation, but access to the glass has been restricted. The area where the glass is most concentrated has been placed under military control by the Libyan government, citing the need for artifact protection. Satellite images have shown signs of excavation activity in these areas, but no further research has been made public in over a decade. What are they hiding? Why is this remarkable material, which could change the course of modern technology, being kept from the world? Could the glass be the residue of a nuclear-like event from antiquity? Or perhaps a product of advanced ancient technologies that were lost or deliberately suppressed? The discovery of Libyan desert glass raises critical questions about our understanding of ancient civilizations and their technological capabilities. Top 9. In-can shadow-resistant paint. In 1936, while exploring the remote Peruvian site of Choc Corral, archaeologists discovered something remarkable buried beneath layers of moss and debris. The inner walls of a sun shrine, exposed to the harsh, high-altitude sunlight and seasonal rains for centuries, still bore vivid traces of crimson, ochre, and blue. But what made this discovery so astonishing was that these colors had resisted fading. Unlike any typical pigments that would have degraded over time under exposure to sunlight, the paint was not just surviving but thriving, even in the intense conditions of the Andean mountains. This wasn't just a pigment, it was a technological marvel. The paint, later named Andean Compound Red 5, was composed of organic and inorganic binders suspended in a silica-based matrix. What was truly unique, though, was the presence of microscopic biogenic silica particles, glass-like structures made from plant ash, which diffused sunlight and prevented UV radiation from breaking down the paint. Essentially, this made the paint shadow resistant, preserving its vibrancy despite centuries of exposure to extreme weather conditions. What makes this discovery even more extraordinary is that this type of paint was resistant to microbial growth. Under laboratory conditions, fungal cultures couldn't penetrate the paint, even in high humidity environments. The paint's binder appeared to contain alkaloids or enzymes derived from local flora, possibly processed through methods that have since been lost to time. Some researchers believe the Incas may have used sacred sun plants in the making of this paint, which could have been passed down through generations of priestly knowledge. In 1981, a partnership between Swiss paint manufacturers and Peruvian cultural authorities attempted to replicate the pigment using only the natural materials available in the region. But after 2 years of research, the project was abandoned, with no successful recreation. Shortly afterwards, several samples of the original paint in Lima's National Archive were reported missing. The official reason given for their disappearance was an administrative error, but the case was quietly closed, and the lead researcher left the country. The silence around this mysterious pigment has only added to the intrigue. More recently, satellite imaging in 2010 revealed other Andean structures with similar residual coloration, especially in places like Pumaquiri and Vilabamba corridor, sites that were not open to the public. These areas have since been sealed off for cultural conservation, with no independent research allowed. Why are these sites being hidden from the world? What were the Incas trying to protect with this extraordinary pigment? Some scholars believe that the Incan sun worshippers may have used this paint as part of a broader system of light manipulation or even sacred geometry. The paint's properties suggest that it could have been part of a larger technological or spiritual framework, possibly even acting as a solar capacitor that harnessed the power of sunlight in ways we are only beginning to understand. This raises questions about the Incas' knowledge of material science, which seems far ahead of what we believed was possible for ancient civilizations. If the Incas had developed a paint that resists sunlight, moisture, mold, and decay without using modern synthetic polymers, it suggests that they understood advanced chemistry and materials science long before modern civilizations did. Could the knowledge of such a material have been lost intentionally? Why are we still in the dark about such a breakthrough? The mystery surrounding this ancient paint makes us wonder what other technologies or innovations the Incas may have had that have been lost to history, deliberately hidden away, perhaps to prevent the disruption of modern industries. Top 10. Chinese flexible glass. In 14 CE, during the reign of Emperor Wang Mang of the Qin dynasty, an extraordinary event occurred in the imperial court that would later spark confusion and mystery for centuries. A craftsman presented a unique gift to the emperor, a drinking cup made from flexible glass, a material that did not shatter when dropped, but instead bent and could even be reshaped with a small hammer. The emperor, intrigued by this unbreakable glass, asked the craftsman how it was made. The craftsman refused to reveal his secrets, leading to a tragic and drastic response. The craftsman was executed and his workshop was destroyed. The secret of creating flexible glass was lost, and it seemed to vanish without a trace, until modern technologies began to closely resemble it. The story of flexible glass was long regarded as a myth, a tale passed down through imperial annals, but written off by many as apocryphal. However, in 2012, modern technology companies introduced flexible glass in the form of materials like willow glass and gorilla glass, used in everything from smartphones to solar panels. What's extraordinary is that this modern glass shares many of the properties described in the ancient texts. Glass that bends but doesn't break and has remarkable strength and flexibility. Despite the similarities, no surviving sample of the original flexible glass has ever been found. However, archaeologists have uncovered fragments of early glass from Luoyang and Chang'an, ancient capitals of China, which defy categorization. Some of these fragments contain rare alkali metals and boron, elements used today to create lab-grade borosilicate glass. In 1999, the Chinese Academy of Sciences published a study that examined a shard with high levels of lithium silicate, a compound that reduces brittleness and increases heat resistance, characteristics that are vital for flexible glass. Yet this study was mysteriously withdrawn and never translated into English, leaving the secrets of this ancient technology buried. During the early Han Dynasty, there are court documents that briefly reference a clear stone that was said to bend but not break, a description eerily similar to the flexible glass. After the craftsman's execution, these references disappeared from historical records. What happened to this incredible technology? Why was it silenced? This lost knowledge of flexible glass raises questions about how advanced the ancient Chinese were in material science, long before modern chemistry and physics. In 2008, an anonymous white paper circulated within the Chinese materials engineering community, claiming to have discovered an ancient silica anomaly from a tomb site near Shuhu. The paper described a material that could bend up to 12 degrees without cracking and could retain structural memory, much like the modern flexible glass we use today. However, this paper was never officially published, and the sample was never revealed to the public. The paper was pulled from circulation, and the subject was never explored further. Could it be that the knowledge of flexible glass was suppressed because it represented a technological leap far beyond its time? Today, the production of flexible glass requires precise thermal treatments, chemical doping agents, and clean room conditions that weren't available in ancient China. So how could the Han Dynasty craftsmen create such a remarkable material without any of the modern tools we have today? Was this knowledge lost to time, erased by the execution of a craftsman? Or was it deliberately hidden to prevent its rediscovery? The story of the flexible glass hints at a much larger technological story, one that suggests ancient civilizations were far more advanced than we typically believe. As we look back at these 10 incredible materials, one thing becomes clear. The civilizations of the past were far more advanced than we often give them credit for. From concrete that withstands the ocean for millennia to swords stronger than steel, these materials carry knowledge that could have revolutionized modern industries. But what if the real mystery isn't just the materials themselves, but the deliberate suppression of the knowledge to make them? What secrets are still hidden, buried beneath the sands of time? These discoveries challenge what we know about the development of science and technology throughout history. The loss of these materials and methods isn't just a cultural loss. It may have been a deliberate act to keep certain technologies hidden from the public. The suppression of this knowledge may cost us far more than we can imagine, and the possibilities that could have emerged from these ancient discoveries are mind-boggling. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more mysterious discoveries. Thanks for watching, and stay tuned for more fascinating stories from history.